Hello and welcome to Whiteboard Science, the series where we give you a quick rundown of a scientific topic to enhance your scientific knowledge. My name is Ray, and today we're diving further into Standard PCR. So, we now know PCR, or Polymerase Chain Reaction, is a method used to amplify DNA. But the question now is, how? For Standard PCR, which of course is the most basic of PCR techniques, all you really need is double-stranded DNA template containing your target, the one we need to amplify, DNA polymerase, which synthesizes a new complementary DNA strand, a buffer containing magnesium, which is critical for the activity of DNA polymerase, and lastly, a thermocycler, which automates the process. With everything ready and prepared, the actual PCR mechanism is simple. First, double-stranded DNA is heat denatured, then the next step is annealing, where primers bind specifically to that single-stranded DNA from before. Finally, the primers are then extended by DNA polymerase using dNTPs, resulting in 2 copies of the original DNA strand. Congratulations! You just got a 2-for-1 deal on DNA. Now, this cycle is repeated not once, not twice, but anywhere between 20 to 40 times. That's usually how many cycles it takes until the amplified product is, amplified. Now, since PCR is a highly sensitive method and very small volumes are required for single reactions, something called a master mix is prepared. And no, not a DJ master mix. The PCR mix is important though, for ensuring that each reaction will contain the same amount of pizzazz. And it's all to keep the PCR party going for as long as your research needs. Oh, and here's a fun fact. Many suppliers, such as Enzo Life Sciences, offer PCR mixes that already contain everything you need for your own PCR party in the lab. Don't believe me? Just check out enzolifesciences.com/PCR, and we'll see you next time on Whiteboard Science.